level lesson. So the last Cambridge written homework will be given in the next lesson. All right. So we've got this. Bye. Have a good day. I see you divided by 2, and you've got aluminum in positive 3. Do we really have to do all that work for aluminum? Not at all. Not really. I know it's in a compound, it's just going to get its likely starch. You could just prove it, but like, it's got to be plus 3. Plus 3 times 2 is positive 6. Minus 1 times 6 is negative 6. It works. That's why I said this method is the long way. It will always work, but it's more tedious. Yes, there's a lot of examples because oxidation numbers is actually really heavily tested by Cambridge and redox in general, so you've got to get it down. You'll see the Cambridge questions. They'll ask, usually it's about redox itself, but sometimes it just asks what's the oxidation number in all of these different compounds on your reactants and the product side. And yes, there can definitely be questions asking just for oxidation number, and that can be points on a Cambridge test. So it's not hard, it's just, like I said, you need to practice it. NH3. What will we do here?
H is always plus 1.
Right.
So I constitute.
Correct. Does that make sense to everyone?
Yes.
Hydrogen is plus 1. Plus 1 times 3 is plus 3. It has to be minus 3. Which is also normal. All right, what about ClO2 minus 1? What would the oxidation number of chlorine be here? Assuming this is recycling. Hi, not today, sorry. If it's recycling, I wasn't here all week, so.
Where from?
All right, ClO2 minus 1. What should we do? You can set it up like this. Or you could set it up the quicker way. Either way. But you've got 1 chlorine and 2 oxygens have to add up to give you a charge of negative 1. So chlorine plus 2 times negative 2 plus negative 1. Positive 3, right?
Yep.
What about CaC2O4? Oh, these are repeats. Yay. I think there's 2 repeat slides. That's why it seemed like so many examples. Yeah, because there's going to be a double here and here. Perfect. So this is the last example. That's why it seemed like there were so many. There's 2 repeats. All right, CaC2O4. What do we do here? If you weren't told, or if you were told to give the oxidation numbers of everything, how would you know you were looking for carbon? Like in these examples, this is overly simplified because it's the first set of examples. But how would I know if I were just given, because Cambridge questions are going to be more like, find the oxidation numbers of everything. How do you know you're searching for carbon?
Because oxygen is always negative 2 and calcium is group number 2 with
Right. And so one way to remember that's a great astute observation one way to remember is the first element of a polyatomic ion or the middle element when there's three is the one you will need to solve for. Why is that? Well, we know calcium is the least electronegative, so it's going to have a positive charge. We know oxygen is the most electronegative, so it's going to have a negative charge. And so carbon falls somewhere in the middle, and you have to figure it out. Like if it gains or loses and how many it does. So, did you get it?
Maybe calcium.
Positive 2 is what you got?
Yeah, I mean that's. It's all equal zero.
Everything equals 0 here. So I made my little equation. I said I have 1 calcium, I've got 2 carbons, and I've got 4 oxygens. I know that all of that adds up to 0. Because that's got to be the overall charge.
So I got
Each calcium is plus 2, each oxygen is negative 2. So
finally.
that sounds right. Minus 6. 2p minus 6 equals 0. And then 2 carbons equals positive 6. Divide by 2. Divide by 2. Each carbon is positive 3. So that's oxidation numbers. You have got to be able to figure out oxidation numbers for any element in a compound. Yes. The second method? Sure. For CaC2O4, I'm going to use the big one up here. So using the second method, I would do negative 2 times 4 for oxygen, which is negative 8. I would do positive 2 times 1 for calcium is positive 2. I know the whole thing has to be equal to 0. So plus 2 and what number? Minus 8 would be 0. It's got to be positive 6, right? So 2 plus 6 is 8, and 8 minus 8 is 0. But then that positive 6 has to be shared in between 2 atoms. So it's going to then be, each one is positive 3. Does that kind of make sense, the second method? Yeah? Pick which one you want to use. Both of them are fine. Personally, I actually like this one because I can work out the mental math in my head like that. But if this is more clear for you, it makes sense to write it out, then do it like that. Before moving on, there's something really important. When you answer the oxidation number for an element, you are answering for each atom. A very common mistake that people make, that students make, is in a compound like this, when they ask for the oxidation number of oxygen, to write negative 8. The oxidation number for oxygen is never negative 8 because oxygen cannot gain 8 electrons. Oxidation numbers are always given for each atom. So that means oxygen is minus 2, carbon is positive 3, and calcium is positive 2. This is something that a lot of students make mistakes on, so be careful. When you answer the oxidation number, you answer for each atom, not the total of them yet.
I just 3, 7 plus.
I would be wary. There are some times in the mark scheme where if you don't put a plus, they won't give the mark on certain things. So, right. But I think it will be okay here if we just read through. All right, redox reactions. So, the other part, after oxidation numbers, is what do we use this for? What's the point? And so, when I was talking about this back reaction back here, the oxidation of iron, or the reaction of rust, this is an example of a redox reaction. A redox reaction is simply a reaction in which there is a transfer of electrons between elements. So redox, yeah, there's some big fly. Apparently it's been in here since the other day. Was that the other day? Yeah. Well, if any of you are brave, it's not a bee. It wasn't here last week. All right. So redox itself is actually a combination word. Redox stands for reduction. That's where the red comes from. And oxidation. So redox actually describes two processes that go hand in hand with each other. Oxidation, the old term oxidation meant gain of oxygen. That's where the word oxidation comes from. But it can also be recognized to show any element that has lost electrons, we say has been oxidized. And so going back to the example, how does that fall in line with the example I showed earlier? What is the oxidation number of iron by itself?
I mean, that's not right.
0. What's the oxidation number of iron by itself?
Yeah.
0. What's the oxidation number of oxygen by itself? 0. Pay attention here. We said that we're adding oxygen to iron, right? We're oxidizing iron. As a result, what happens to iron?
It rusts.
It loses 2 electrons, right? It loses 2 electrons and it gives them to oxygen. And so iron has lost 2 electrons, and we say that iron has been oxidized. Oxygen gains electrons, and we say that oxygen has actually been reduced. And so these two processes happen in tandem with each other. A reduction means a loss of oxygen, but it can also be described for any element that gains electrons. So you've got to remember that losing electrons is oxidation, and gaining electrons is reduction. This is one of those concepts that a lot of people don't love because you're working with electrons. Electrons are negative, right? And so if you lose electrons, that means your charge actually becomes more. And so I had a student who came up with this acronym. The oxidation more positive. And then just remember that reduction is the opposite. Reduction would then be more negative, right? So reduction would be more negative because you gained electrons. And so this is going to talk about, when we talk about redox, we're talking about chemical reactions, and we're talking about processes. David, are you okay? You okay? Okay. So we're going to talk about the gain and loss of electrons in chemical reactions when we talk about redox. Now, this is just an image showing what's happening. The ion that becomes positive, if you start with a charge of 0, the ion that becomes positive, that would be oxidized, and what becomes negative is reduced. All right, so let's take a look at when magnesium has a +2 charge, what happens to its 2 valence electrons? Ejected, right? Goodbye. Goodbye to electrons. They went somewhere else. So notice that the oxidation number goes from 0 to +2. This is an example of an oxidation. And so an example of reduction, with the valence electron shown, let's take a look at sulfur now. Sulfur starts with 6 valence electrons. When it forms into a compound, it would become S2 minus, which means instead of having 6 valence electrons, it would actually have 2 minus. It had 6. 2 minus charge means what? Gains 2. So it actually has 8 electrons, right? It gained electrons. Its charge goes from 0 to -2. We call this a reduction. So what you're going to have to do is you're going to have to pick out what element's been oxidized, what element's been reduced in a chemical reaction. Yeah. Go ahead.
It's 2 negative. Does it matter if I write negative?
Which one? Oh,
Yeah,
this.
that,
Can't reduce it either. Technically, and I always do it one way or the other, back and forth, I do +2. Technically, 2 minus is the better way, because it shows it's a charge you're not subtracting. That's why. But it can be written either way. All right, so you can also, there's other acronyms you can use. Like I said, I like this one that a student came up with a while ago. Oxidation more positive. There's some other ones that exist to memorize what's going on. Leo says GER, lose electrons, oxidation, gain electrons, reduction. Leo says GER. Lose electrons, oxidation, gain electrons, reduction. And then there's another one that people like called oil rig for several different. Oil rig is oxidation is losing, reduction is gaining. So people use, this is definitely a place where acronyms are used a lot because otherwise it's easy to get confused with redox. Because like I said, with electrons, because everything's negative, everything's going to be the opposite of what you usually think. Before moving on, if you have a chemical reaction and it is redox, if one element is oxidized, this means that another element must be. You cannot have an oxidation without an accompanying reduction. If one element loses electrons, another one must gain. So that's important to know. And then the final thing here, before we get to some practice exercises, is what is an oxidizing agent and what is a reducing agent? I don't know if you remember this, but whatever is reduced causes the other element to be oxidized. And so going back to the example, if I look at, let's take a look at Mg plus S goes to MgS, which is the one that I had just showed. We have this with the valence electrons, and then we've got magnesium lost all of its electrons, and then sulfur has all 8, right? So looking at that, just as a quick example of a simple reaction. Magnesium's oxidized, we said. Because it lost electrons in this reaction. It goes from having its 2 valence electrons to not having them. It's oxidized. Well, what happened to its 2 electrons? What happens to magnesium's 2 electrons? Where'd they go? They went to sulfur, right? So, without magnesium, sulfur wouldn't have its electrons. Like, it wouldn't be stable without magnesium. So magnesium caused sulfur to gain electrons. Would you agree? Magnesium caused sulfur to gain electrons. So that means magnesium was oxidized, but it caused sulfur to be reduced. So when we use the term agent, we're talking about the action upon the other element from that one. And so magnesium is oxidized. Magnesium causes sulfur to be reduced. So therefore, the magnesium is also known as the reducing agent. Another way to memorize this, once you figure out what's oxidized and once you figure out what's reduced, the agent is always just the opposite. So I would just remember that it's flipped around whenever you're looking for agents. That's why I said it ends up being confusing because these terms are backwards. And it's because when you look at reducing agent and oxidizing agent, you're looking at action on the other element. Because of this element, the other one was oxidized. All right, so let's take a look at some practice questions for readout. And then I'm pretty sure we have some paper questions coming up yet. So, first one. The first step is, of course, from the textbook. Deduce the change in oxidation number for the bolded atoms. And for that specific process, is it oxidation or reduction? And is it the oxidizing or reducing agent? So let's take a look at the first one. Bromine is bolded. So what is the oxidation number for Br2? What's an element? It's 0. Why is this a different element? It's equal. We're good with that? All right, on the other side. Br has a -1. What's its oxidation number? Right, that's that rule. All right, so bromine goes, this is what you have to recognize. Bromine goes from 0 to -1 from reactants to products. Is that an oxidation or is that a reduction?
It's a reduction. Yes.
So, what are the ways you can look at this and know that? Reduction means reduction in charge, literally. If the number goes down, it becomes more negative. That's a reduction. Another way to recognize it, it has more electrons. And that's the definition for reduction, is gain electron. More negative. So reduced. So always, if the charge goes down, it's always reduced. If the charge went up, it would have been oxidized. So is this the oxidizing or reducing agent then?
That's the oxidizing.
Right. So for agent, you just got to memorize to flip it. Whatever is reduced is the oxidizing agent because the other elements be oxidized. It took the other element's electrons away. All right, so that was the first example. We'll do a couple more of these from the textbook. Example 2.
Oh, that's.
Does that make you unsettled?
No.
How are we gonna get nitrogen on the left side? What?
Oh, I wrote this on the wrong slide.
Okay, let me give you a trick. Do you know what this polyatomic ion is? That's ammonium, y'all. If you know it's ammonium, if you know that this is ammonium, then you can just figure out what is the charge of nitrogen and ammonium instead of trying to figure out this whole thing. In ammonium, what's the charge of hydrogen, or what's the oxidation number of hydrogen? +1. +1 times 4 is +4. The whole thing has to equal to +1. What is the charge of nitrogen? -3 is correct. It's just -3. Right? Yes or no? Is there confusion?
Oh, no.
Hydrogen's always +1.
Oh.
What I would do is isolate the polyatomic ion and figure out nitrogen in this polyatomic ion. If you had not done that, you would have gotten yourself very confused because you also don't know chromium. Like if you just broke the whole thing apart, you don't know chromium because it's a polyatomic and it can have, it's a transition metal, it can have multiple various charges. So my suggestion is if you see something inside the polyatomic ion, just separate that polyatomic ion and figure out its charge there. Now what's this charge of nitrogen on the other side? On this side? On the product side? It's N2. What is it here?
It's 0.
So we're going from -3 to 0. Oxidation. Charge goes up. Reducing agent. It's lost electrons from -3 to 0. Alright, I think we've got one more and then we get to look at some Cambridge questions. Alright, 4-3. What do we do here? Could we just crisscross these?
Yeah.
This is going to be +3. And over here it's going to be +5. It goes from +3 to +5. It's ionic. So, and it's just binary, and the oxygen is -2, so it's an easy crisscross. +3 to +5. Charge goes up. Oxidation. It lost electrons. It's got less electrons. The charge goes up. So this is oxidation and reducing agent. Alright, so I think that was the textbook question. But of course you actually have to see what the Cambridge questions look like. So here's question 1. They give you some redox reaction here. And they ask you, what is being oxidized? One of the things that I want to bring up is when answering, always answer a reaction. If you are being asked what is being oxidized or what is being reduced, always answer a reactant because it's what's happening to what's on this side. So, what's being oxidized? How would we go about this? You could start by getting so step 1 find the oxidation numbers. For everything. What's the oxidation number for tin in an SNCl2? Plus 2. Gonna be plus 4 over here. What is the oxidation number for tin in SNCl2 is plus 2, no? Crisscross. Because it's ionic, it means chlorine is -1, yeah. It doesn't always work. It works because chlorine is a -1 charge and because of the way it is. Always the first element, remember, is positive and the second one is negative. HgCl2. What do we do here? Hg is the same thing. Plus 2n minus 1. All right, what about the peroxide? What's the charge for tin here? Plus 4. Chlorine is -1. Then what about Hg2Cl2? What are the charges here? But they're not plus 2 minus 2. Because oxidation numbers are for single element. I said you gotta be careful here. Chlorine is -1. -1 times 2 is -2. This is positive 2 divided by 2 is actually positive 1. All right, first, do you understand where you got the numbers? The oxidation numbers. Which one? This one? If you had went and you did reverse crisscross, let's just be clear, you would come up with Hg plus 2 Cl minus 2. What's wrong with that? You've stuck chlorine with 9 valence electrons. You know that doesn't exist, right? So, how do you fix that? Divide them by 2, right? So when chlorine is -1, then Hg must be positive 1. Yes. Yeah. Exactly. So, any other charges don't make sense, or are the rest of them okay? Any other charges don't make sense. Because this has to be 0. This has to be 0. So this has to be -1 times 2 is -2. And that has to cancel. It has to do that. All compounded. So that's, you're getting confused with the plus 4 minus 1 from group 14. All post-transition metals, these metals right here, some of them can have variable charges. Specifically tin and lead can have variable charges. That's what's confusing you. All right, so are the charges making more sense now? So now can we try to solve the question? We want to know what's being oxidized, meaning we want to know where does the charge increase. The answer is A. Actually, believe it or not, I heard comments. Typically, what students find is they prefer the redox part of this unit than the math part, because the redox part is equivalent to what it was in
I prefer the minus.
You still prefer the math?
Yes.
It is what it is. But I can tell you for sure that most of the time students are happy to see some redox on this test and not just with math. So it's not just a complete like math test. It'll be about half math. Half the questions will be math. All right. So let's take a look at the next one. In which reaction is the species in bold? Which I'm going to underline them just in case it's hard to see. Because this is an old question and it's kind of brainy. So in which species is the bold agent acting as the oxidizing agent? Now the first thing I would do is I would literally cross this out and say reduce. Because I myself get confused sometimes with all the back and forth with the words. So whenever I see agent, I just say, okay, I'm looking for a reduce, which means I'm looking for the charge to go down. You're looking for GERD. Yes. So then, now that we have that information, which of these is reduced? Is it calcium? In A, it goes from 0 to +2. So is that the answer? What about B? SO3 2- to SO4 2-. What happens to the charge of sulfur here? The oxidation number. It goes from, I guess if you want to work it out, it would be SO3 2- going to SO4 2-. What do you think? Is that reduced? I mean, if you look at it, the original definition has got more oxygen, right? Which means it's actually been oxidized by definition. If you work out the numbers, so it's definitely not the answer. But if you work out the numbers, this would be +4, and this is +6. If you work out, it does get oxidized. C goes from 2+ to 0. That is clearly reduced. No. No. What did I tell you all? Multiple choice. If you come up with what you know is the answer, stop. That's the pro stress. Okay then. All right, we've got just a couple more things to go over. All right, half reactions. So this is going to take us a little bit into what you're going to see in part 2. So a half reaction I've sort of shown you, but I've never combined them into full reactions. A half reaction describes only the oxidation or only the reduction taking place. And so when I had showed you the example here, back here with this, these are actually half reactions. This is saying magnesium lost its 2 electrons, that's the oxidation. Sulfur gained 2 electrons, that's the reduction. So when we separate a chemical reaction into only what's happening to one element or what's happening to the other element, we call those half reactions. They're simply telling half the story. Something important about half reactions is that electrons have to be written here to show if electrons have been lost or if electrons have been gained. And when you combine half reactions together to form full reactions, the electrons are going to have to cancel. So however many electrons are gained by one element are lost by the other. So go ahead and see if you can construct a couple of half reactions. You don't have to use the valence electrons, but write a half equation for potassium losing an electron. What would that process look like? Just potassium losing an electron. for the electrons.
Right, so oxidation is the opposite of having to.
Yes. Yes. You don't have to show the state of matter, but it does. Yes, you may.
There's just one electron, and it has.
Try both of them. Let me.
Yes.
Wait. Oh, it's you.
Oxygen with a negative 2 charge.
I was writing before. Okay. So let's go ahead and go over it. Potassium goes to K plus 1. You also have to write what happens to the electron.
Yeah, do we have to write the one?
Yeah.
Write the one.
Well, not the 1 part, no, just the E minus. And then oxygen gaining electrons to become the oxide ion. Now, technically, we're not doing full reaction, so we would just do O goes to O minus 2. We need to place the 2 electrons where we place them. On the reactant side. Because they're going into oxygen. That's the reason why. So O plus 2 E minus goes to negative 2. All right, let's try another one. This is write 2 half equations for this reaction. Can you figure out what the 2 half equations are in this reaction? And then state which one is the oxidation and which one is the reduction. So separate this into the 2 reactions.
What's the other one? Oh, we have second one here.
For what? What?
What if it's here? Doesn't that really stable?
Wait.
Does that mean that it's already a normal gas?
That's a good point.
The answer is NA.
Later on, no, later on, It will happen. That's not right. That's electronegativity. All right. So Cl2 goes to 2Cl minus, right? Are we good with this? What am I missing? In the half reaction, you also include the extra electrons that are added in. And so 2I minus goes to I2, and where would I put the 2 electrons here? There's 2 of them. I broke these reactions into their 2 halves, right? You have to include how many atoms you have. If you have 2 of them, that means there's 2 electrons that have been gained. Yes. Like if you did the Cl2 and then the 2E minus, that's fine. The same thing. All right, try this next one. Separate into the half reactions for this one. Separate into the half reactions.
Oh wait, because it's games. I'm stupid.
I did? Wait, are you missing a page?
No.
So there's just an extra one there. Okay. It's still 0. Because it's still just that element. Go ahead.
That is hard.
I mean, he kind of made the calculator.
Very helpful to us.
Now we can do chemistry easier.
Yeah?
Now we can do chemistry easier.
I guess
To the left guy.
chemistry, but in math, you hate it. God, I hate it.
Wasn't Pascal?
No.
Wait, I'm pretty sure Pascal was.
You would still need to do the things you do,
Well, yeah.
just
but,
without
like,
his formula,
I
which would
need-
make it a lot harder.
I need someone to blame, and I'm blaming him.
You can always,
Everything.
We should blame,
you know what I do. You can blame Hayden.
This is right, right? Okay. So, I have broken it up into the 2 halves, but I have left out the electrons. So, how many electrons have been transferred here?
4
And for this one, which side is the electron?
on the right side.
And so that means in this one, the electrons are on the left side. Like that. Okay. So, before we go, here's the deal. Your homework's going to be easy, meaning it's going to be at the pre-8 honors level. It's going to be a quizzes where you have to, within 3 attempts, get 80% right, and I put 100% in the grade book. And I'm not giving you the Cambridge questions yet. But I'm going to do an end of class challenge. I'm going to give you another opportunity for that point today. but it's not going to be easy. The next question. Exactly. In a reaction between hydrogen iodide and concentrated sulfuric acid, the products are hydrogen sulfide, sulfur, iodine, and water. Write an equation for this reaction. Now, what I'm going to tell you, I'm going to go ahead and give you the reactants and products. Just a little bit of a crutch. But I'm asking you to figure out how to balance this equation. That is your goal.
Yeah, we can. Oh, this is pretty easy.
We can use it.
That is the goal. Balance the equation.
Oh, wow. Okay, so we gotta start with iodine. That's the one that's alone. That was the one that's alone.
I'm giving you 15 minutes.
That's
That means there's two times. That means that there were four two times zero.
a big problem. A big problem. Because if you look at the H2O, right, and the H2O4, every time you add one to the H2O4,
You've
remember,
got
one is there
15
on-
minutes.
So you're gonna flip it.
So the difficult question is here, not in the homework.
But if you solve the opposite,
It's not impossible to solve. People have solved it before. It's just not easy.
we got the acid. Okay. Long as you get the first one. Even okay,
Hold on 1 second. I'm about to.
how many
Close, but not quite. It's off a little bit.
What's on? What's HUR that do?
It's not easy.
No, we have one. Just one.
You don't even try that.
You actually have 10. Okay, I finished. That's my thing, honestly.
Okay. Yes.
You get it. Yes, you should check it.
Justin, you can go ahead and write it up on the board, friends. For this one, as long as even one person got it in the class, I was going to give the point. So, round of applause. Justin got it. I'll give you the marker. Here. You just have to fill in the numbers in front. That way I can go over the last part before we go. You can all check to see how close you were.
I didn't get past the 10. Like, I got to 10. I think it's 12.
Yeah, you had 2 extra of each. All right. So I think this is 7 items, right? 7's there. All right. So that's an example of a balancing equation question that I think is kind of wild. And a Cambridge time waster.
I was close. I got the first number wrong because I can't count.
I got the last one right.
All right. So let me hold your attention for just one more minute. Take a look at the last 2 points here. They're actually kind of simple, and they're kind of common, meaning that whenever oxidation shows up, this is typically the question that's asked. The top one, not really, but the bottom one for sure. They'll say, explain with reference to oxidation numbers, why is this redox? So what do you have to say? How would you prove this is redox? How to prove redox? So how to prove redox is you have to say what the change in oxidation number is. Just what changes. So in order to get the 2 marks here, 1 mark would be for saying that iodine goes from -1 to 0. So the oxidation number of iodine changes from -1 to and where would the other point be? Whereas the oxidation number of sulfur changes from, this is +6 to -2 and 0. From +6 to -2 and 0. So you have to, for 1 mark, you would state the change in the oxidation number of iodine, because that's one of the ones that changes. And then the second mark is to do the oxidation number change of sulfur. Make sure you write this down just in general so that you know how to answer for oxidation number changes. This is a very common type of paper 2 question, the bottom part. The top part with the crazy balancing, that's actually an uncommon question. It's an uncommon question. That doesn't mean, like there's uncommon cards and like, doesn't mean it's impossible, but it's uncommon. The one on the bottom is a common question. It's a very common question. 2 semi-free points. But easy in can also mean easy out. So don't lose easy points when they show up. Don't skip the whole thing because you saw the first question and were like, hell no. And then you were like, not doing any of this. Because usually Cambridge will sandwich their questions. They'll have a hard question and then there'll be an easy question. Yeah. So don't just like look at a question and be like, I don't want to do this whole page because this top question is hard. Yeah, it's a good way not to pass. Find the easy questions. Oh, by the way, and I told this to other classes before, whenever a question says this was balancing, that's scary. You want to put that. If they give you, you may wish to use oxidation numbers, it means they're giving you something very difficult to balance. And Justin did not use oxidation numbers to solve.
How could you?
What do you mean?
You would look at the change in charge and try to finesse like how to come up with how many electrons transferred. We give you those numbers. So
Good afternoon, Golden Lions. This is Devin, and your afternoon announcements. Students, please remember to check your uniform daily and report to school in proper setting uniform. Make sure your outerwear is colored white, black, or red. Also, please wear your student ID badge around your neck.
somebody remembered. Somebody remembered. All right, I have.
To replace an ID, you must pay for it on the lowest fee. Students who have unpaid balances will not be allowed to participate in field trips. Yearbooks are on sale now for $60. Price will increase after December 20th. Please visit www.yearbookorders.com to order. Order number is 21027. Tomorrow we wrap up the Spirit Week with a jean today. Wear your favorite color jeans for your uniform or Spirit shirt. Torn or ripped jeans are not allowed. Cost to participate is $1. Attention FFEA members. FFEA will be meeting on Monday, November 6th after school in the auditorium. Students, all after-school tutoring has been canceled for today. Teachers, please report to the auditorium at 2:30 for our faculty meeting. This concludes our afternoon announcements. Enjoy the rest of your day, CIE.
Rosalind?
Also, detentions will be after school in Miss Sauer, so please be on time.
Alan?
You guys are equally smart.
Correction. There is a faculty meeting this afternoon. Those students that have scheduled detentions today, you need to do it in the main office, so please be on time. If you do not appear, that is double. Again, you need to make sure on your Hero app, if you have a detention schedule, you need to be in the main office on time. Again, faculty, there is a faculty meeting after school today. Thank you.
David?
See, understand. It's on your side.
38.
Yeah.
A lot of C levels on this test.
That's good.
Good?
I got it.
You got 38 points.
So, it's because of the back.
Well,
It's because of the back. I
it's a
second guessed
more
myself.
better by 1 point.
I second guessed myself.
By 1 point.
I'd have done so much better if I didn't second guess myself on the back. The back was
It was beautiful.
It was. I was so confused. Oh, I didn't do that. Like the easiest question. Where the hell did I get wrong?
Yes. Maybe that's a right. I'm gonna move back. Yeah, you got it.
I do agree.
And the Snickers is wild.
I noticed when you had the recently. That's why. I put them in the comments.
Oh, yeah.
Oh, you must give them one.
Oh, that's what they wanted. I didn't know if they wanted this question. I just put 29.
Put 29.
That's the I don't know what I'm doing. I just feel like 20 something.
In the
Oh my goodness!
Well, I
Eating in here?
No,
I did not understand.
Alright, let's shut those down.
I didn't look like all of this.
Don't forget to put the desk back.
You know, let's go to that rapper.
The way they worded it.
You gotta get
Yeah, that gives you a good
Did you pass out of it?
That's what the bus has.
He's category.
He's categories.
431.
It doesn't change your level.
If we had them to bang, we would have been $15.
Wow. That's incredible. Bye. Like four of you that got the same answer. Like different questions, but. Hi.
At this point, I'm pretty sure she did. No, probably. No, I think I'm gonna go take points.
On the math part, she told me that I should have done work, but I just put random numbers.
I did the right answer. I just did not show work because I did not know how to do the math.
Have you fixed that with empirical formulas yet? Because
I just okay. I did it. I understood it completely. Then I forgot.
oh no. Boring is the worst.
Because I did it like late at night, so I was reading through it, and then when I woke up, it was just gone.
You know, y'all know I went to school this week probably only just for this class today. I got the flu last Friday. Like, bad. I had a fever for 5 days. Yeah. So I came here today because I was like, I got to try not to miss that AS class.
I mean, if we still had Zoom, it would have been a perfect.
So I thought about that. I even thought about that, but I was like, I don't trust the sub that they will put on the Zoom. Like, I don't know if they will do that. That was what I was worried about because I actually thought about, even on Tuesday, I was like, I could probably just at least for 2 hours, I could get on a Zoom and teach a thing. I'm pretty sure I could. But I couldn't do like 8 hours, that's for sure. And that day I still had a fever. I was like, but yeah, if I could have taught over Zoom, I would have done
No, I
that.
didn't do that.
You just get it.
I'm telling you,
Bye.
to the
I
math,
just
I put
going
24,
through
25, and
when I-
29.
Like back during COVID, because I had this laptop, right?
Yeah.
It was a little old. And
A
it would
little?
start freezing when Zoom would start up. So I would constantly be